Okay, good morning, everyone. And for this discussion, we are going to continue statistics and probabilities uncertainty topic, but this time we will have conditional probability and multiplication rule. Uncertainty, um, this has been originally derived or discovered by gamblers, as funny as it may seem, because they wanted to increase their winnings or at least decrease their losses. And according to Albert Einstein, God does not play dice, and it is an idiomatic expression, which tells that if you would look at things, it seems that everything has been planned, and this is part of a grand design. Okay, just like Earth being in the Goldilocks zone, and things that we have to take into consideration as why we are all living in this planet. Okay. Yet, there are still many events, especially in nature, that seems to display random behavior. And in many real life situations, we will be able to model this by random processes. And thus apply probability to understand the behavior of these situations. So um, let us play a game first now before we continue. Let's say there are two boxes and both boxes contains 1,000 pesos and red cards. If you get 1,000, it is yours. If you get the red card, you will pay 500. So which box will you draw from? Will it be box A with three red cards and two 1,000 bills? Or will you select box B with 30 red cards and 20 1,000 bills? So you can pause this video and think which one will you select. If you're done selecting, then let us continue. So in my experience asking this to the class, the answers are always split. They have their own reasons for selecting box A, and there are others who also have their own reasons why they have selected box B. But the reality is that it does not matter what you pick. Okay, because box A with three red cards and two 1,000 bills is 2 out of 5 or 40%, while box B with 30 red cards and 21,000 bills is 20 over 50 or 40%. So no matter which box you select, you have 40% of getting 1,000 pesos. So the probability is the same for both box A and box B. So in relation to this, let's talk about conditional probability. So when you say conditional probability, these are events that has extra information that can change the probability of an event. So let me underscore can change, meaning there is a possibility for the event to change because of this extra information. Like let's say you are doing a survey in the mall with different people coming from different locations. And what you wanted to find out is A, the event that the respondent is from Luzon, a certain barangay here in San Jose del Monte. And B is the event that the respondent is male. Okay? So we have a way of computing for that, which is a probability of A over B is equals to probability of A and B plus A and B divided by probability B. So let's look on how we can solve these conditions. So event A and event B is equals to 235. So how did we arrive at 235? It is 85 plus 150. Because again, if you would remember, event A is that the respondent is from Luzon. So what we have done is we have added this 85 plus 150. Therefore, you have 235. Okay. Now, 283 is the event that the respondent is male. So all you have to do is just add this, and then you have 283. 235 plus 283 is equals to 518. So this is your top player, okay? The numerator. And then for the denominator, event B, is 283 because again, event B is the respondent is male. So we just took it at plugged it here, and then we now have this 518 over 283 computation. So let's try to compute for that. 518 divided by 283 is 1.83. Okay, so you have a chance of 1.83% to get a respondent that is male and coming from Luzon. Now, we come to the second type, which is independent events. So when you say independent events, there are extra information that may not, okay, let me underscore that, may not really change the probability of an event. So earlier, okay, conditional probability, extra information can change. But for independent events, the extra information may not or will not really change the outcome of the event. Because those two events are independent, probability A and probability B. And this is also called the multiplication rule. So intuitively, we call events such as tossing a coin or dice several times independent since future tosses are not affected by previous outcomes. So this is true. No matter how many times you toss a coin or a dice, the outcome is still unpredictable because past events do not predict the future events. So, for example, we wanted to roll a snake eyes. When you say snake eyes, these are both ones in a set of dice. So, what you will do is just multiply 1 over 6 by 1 over 6. Why? Because there are 6 outcomes in the dice. That's why we have placed 6 here. So 1 over 6 times 1 over 6 is 1 over 36. Meaning that the probability of snake eyes is equivalent to 1 out of 36 or 0.277. So 1 over 36 is 0.277. Okay? And if you would look at this chart, you can see that the snake eyes is just one of the 36 outcomes. This one. So now let me give you this activity and you can answer this on your own. If you need answers to this, you can feel free to send me a message and I'll let you know what is the answer. Okay, I hope you have learned from this very short topic and feel free to follow me on all of the social media platforms I'm in. With that, thank you so much and I will see you on the